In this video, we're going to talk about dividing radical expressions. So your first step is to divide your coefficients, meaning the numbers in front of the radical, and then use the quotient rule. So the quotient rule says that if you have the nth root of a divided by the nth root of b, you can actually make this into one big radical and divide a by b. So once you do that, then you simplify your resulting radical. So let's look at an example. Number 1, we have 12 square root of 160 divided by 2 square root of 5. So first, divide your coefficients. Well, 12 divided by 2 is 6. Then we can use our quotient rule, and we can divide 160 by 5. Okay, which will give us 32. So we will have 6 square root of 32. Then you simplify your resulting radical. Okay, so break down 32. You get 2 and 16, and then 4 and 4. So groups of 2, and then this guy's left over. So the resulting radical, I'm going to move it up here, we have 6 times 4 square root of 2. Well, 6 times 4 is 24, so we get 24 square root of 2. Let's look at another one. So we have 36 fourth root of 1,250 divided by 9 fourth root of 2. So a key to dividing radicals is that the index has to be the same, okay? Otherwise, this is not possible. So divide your coefficients. 36 divided by 9 is 4. And then you can divide the insides. So 1250 divided by 2. Well, that's going to give you 625. 625 is actually a perfect fourth of 5. Okay, so you will end up with 4 times 5, or 20. We can also divide radicals with variables in them. In this example, I can make this one big radical, and so x cubed y to the 9th divided by x squared y to the 5th. So just divide your variables. X cubed divided by x squared. That will give you x, okay? Y to the 9th divided by y to the 5th. 9 on top, 5 on the bottom, you would have 4 left over. So we would have y to the 4th. Simplify the resulting radical. Well, I only have one x. I can't break that down anymore, but I have 4 y's, and I'm looking for groups of 2 because this is a square root. I have 2 groups of 2, so they come out as a y squared, square root of x. That's my final answer. Number 4, we have the cube root of 7x to the 5th divided by 64y to the 6th. So you can see if you can simplify 7 divided by 64. Well, 7 does not go into 64, so you can actually use your quotient rule backwards. We can actually break this apart and simplify the radicals by themselves. So if I look at the cube root of 7x to the 5th, well, I can't break down 7 anymore, but let's look at x to the 5th. So 1, 2, 3, 4, 5 x's. I have one group of 3 and 2 left over. So my resulting radical is x cube root of 7x squared. Let's look at the denominator. Cube root of 64y to the 6th. So 64 is actually a perfect cube of 4. And then we have y to the 6th. So let me actually move that guy around. So I have 4, and then y to the 6th. So 1, 2, 3, 4, 5, 6. I'm looking for groups of 3. I have 2 groups of 3, nothing left over. So the denominator simplifies to 4y squared. So let's write this out. The numerator is x cubed root of 7x squared divided by 4y squared. This cannot be simplified anymore. That is your answer. Now let's talk about rationalizing the denominator. Whenever you are simplifying radicals, your final answer should not have a radical in the denominator. That's like ending a sentence without putting a period, okay? It's not mathematically correct. So there are two ways to do this. If you have a monomial in your denominator, meaning you just have one term, you're going to multiply by the radical in the denominator. If you have a binomial in your denominator, you are going to multiply by the conjugate, okay? And so a conjugate, so let's say you had a plus the square root of b in your denominator. The conjugate is the exact same numbers, you just switch the sign in between, okay? That's what a conjugate is. So looking at number 1, 3 divided by 2 square root of 5. This is a monomial in the denominator. If it's a square root, you multiply by the radical. So I'm going to multiply top and bottom by the square root of 5. So on top, I will get 3 square root of 5 divided by 2 square root of 25. Well, the square root of 25 is 5. So I get 3 square root of 5 divided by 2 times 5, which ends up being 3 square root of 5 divided by 10. Same thing goes for number 2. This one will have to break up the quotient. So I have the square root of 8 divided by the square root of 15. I multiply by the radical in the denominator, so I'm going to multiply by the square root of 15. So square root of 8 times the square root of 15 is going to give the square root of 120. Divided by the square root of 15 times the square root of 15, whenever you multiply a radical by itself, you just get the number inside. Now you want to simplify, see if you can simplify the square root of 120. So break that down. You can get 8 and 15. So 8 simplifies into 2 and 4. 15 simplifies to 5 and 3. And I can break down the 4 into 2 and 2. So I have my group of 2 there. I have a 2 left over, and a 5 and a 3. So a 2 comes out. 2 times 5 times 3 will give you 30 divided by 15. That is rationalized. There's not a radical in the denominator anymore. Let's look at number 3. The square root of 8 minus the square root of 2 divided by the square root of 2. Again, monomial in the denominator, so multiply by the radical in the denominator. In this case, we are going to have to distribute the square root of 2. So the square root of 8 times the square root of 2 is the square root of 16, minus square root of 2 times the square root of 2 is 2. Same thing in the denominator. Square root of 2 times square root of 2 is 2. The square root of 16 is 4, so we have 4 minus 2 divided by 2, which will give us 2 divided by 2, which is 1. Now let's look at what happens whenever we have a binomial in the denominator. So we have to multiply by the conjugate. Again, the conjugate. If you have a plus the square root of b, your conjugate is a minus the square root of b. So in number 4, I'm going to multiply by 6 plus the square root of 5. Okay, you just change the sign in between. So you're going to have to distribute that 2. So 6 times 2 is 12 plus 2 square root of 5 divided by, whenever you multiply by a conjugate, you only have to multiply your first terms and your last terms. So 6 times 6, 36, Negative times a positive is a negative. Square root of 5 times the square root of 5 is 5. So simplify this just a little bit more. 12 plus 2 square root of 5 divided by 36 minus 5 is 31. Last one, number 5. We have 3 plus the square root of 7 divided by 2 plus 2 square root of 7. We have to multiply by the conjugate in the denominator. So 2 minus 2 square root of 7. 2 minus 2 square root of 7. So whenever you multiply the conjugate, again, you only have to multiply the first and last terms of the conjugate. So only my denominator do I get to do that. The numerator you have to FOIL. So 3 times 2 is 6. 3 times negative 2 square root of 7 is negative 6 square root of 7. Square root of 7 times 2 is 2 square root of 7. Square root of 7 times negative 2 square root of 7 is negative 2 times 7. Square root of 7 times the square root of 7 is 7. My denominator, again, multiply the first and the last. So 2 times 2 is 4, minus 2 square root of 7 times negative 2 square root of 7 is 4 times 7. So simplify this. We can combine those like terms there. So we will have 6 minus 4 square root of 7 minus 14 divided by 4 minus 28. So again, simplify a little bit more. You get negative 8 minus 4 square root of 7 divided by negative 24. Now you can reduce all of these numbers that are in front of the radical. The 8, the 4, and the 24 are all divisible by 4. And since they're all negative, we can divide it all by a negative 4. So negative 4 goes into negative 8 twice. Negative 4 goes into negative 4 once. Negative 4 goes into negative 24 6 times. So our resulting radical is 2 plus square root of 7 divided by 6.